So, I just welcome you to the second session for the fourth module, where we will be concentrating more on the difference between the hydraulics and pneumatic systems. Majorly, why? Because why not with the electric systems? No, this is only because the fluid power engineering will be concentrating majorly on the power transmission, which has been taking place by the use of fluids. That is, either it can be a liquid or it can be a gaseous one. So we will be comparing this hydraulic systems along with the pneumatic systems, and then we will be discussing about different components of the pneumatic systems. And then, as I just told you earlier in the previous session, I'll be concentrating more on the compressed air and why this only air is being used in the pneumatic systems. So basically, as we know, this hydraulics and pneumatic systems. Hydraulic systems is the one which uses a pressurized liquid as a working medium, as a fluid, whereas the pneumatic system is uh, extensively used uses a compressed gas or an air or a pressurized air as a working fluid to do a specific work. Whereas, since so I relate the first difference with the second relation. As we know, the first, as we said, it is uses a pressurized liquid, whereas this uses a pressurized gas. Obviously, my dear friends, as I just told you, the properties, one of the properties is the density. When you take a water in general, a water has got 1000 kgs per meter cube density, whereas the air has got only 1.12. That means 1000 times it is more. So obviously, the pressure with which it is operating will also be more. An oil hydraulic system operates at a pressure of around 700 bars, whereas a pneumatic system which can operate maximum of around in the range of 10 bars. Now even here it is 70%, it is more. So an oil hydraulic system operates at pressure up to 700 bars, whereas the pneumatic it can operate within the limits of 5 to 10 bars. Okay, generally it is designed as a closed system wherein which the oil from the source or the tank it has been taken to the pump and then the pump into uh, the pressure relief valve or whatever it may be different sectors, and then after the actuator it will come back to the return from the return channel, it will come back to the source or the tank. So it is always a closed loop. So we call this hydraulic systems as a closed systems, whereas the pneumatic system is the one which takes the air, draws the air from the atmosphere from a compressor naturally, and it does the work and it will send it to the receiver. Then it will send it once again to the actuator, and after the actuator, it will not come back to the any sources. It will go and it will be leaving it to the atmosphere as usual. That like our open cycle turbines. So it is taken from the atmosphere and it is leaving to the atmosphere. So it is called as an open system. The system slows down when leakage occurs, wherein which in the hydraulic systems what happens? Leakages are meant to occur. Before this point, I want to highlight one more point. It is the leakages are meant to occur more in the hydraulic systems. Whatever the type of seals or whatever, how much ever we, that is one of the major drawbacks of the hydraulic systems, or else hydraulic systems would have been majorly 100% they have replaced any other systems. The major drawbacks of the hydraulic systems is it is meant to occur a leakages. The oil leakage problem is more in the hydraulic systems, whereas in the pneumatic systems leakages are less, very much less, or almost it is neglected in such cases. So that is the reason why the system slows down when leakage occurs in the hydraulic systems, whereas in the pneumatic systems the leakage does not affect the system much. That is the one major plus point of this pneumatic systems. And even because of the leakages, what happens? Hydraulic systems are not clean compared to the pneumatic systems. Wherein which in the pneumatic systems, where the pneumatic system, since the leakage is just in air, we don't have the uncleanliness. That means in the pneumatic system there will be always a cleanliness is being maintained. Because of that, the valve operations are difficult in the hydraulic systems, whereas the valve operations are very easy in the pneumatic systems. Heavier in weight, obviously, since because the more components are being used, and even the capacity of these hydraulic systems are more. First one is the capacity is more and more components are more. Because of these two reasons, what happens, the hydraulic systems are always heavier compared to the pneumatic systems, wherein which pneumatic systems does not require more source or tank or something like that. The components are very less and the capacity of these pneumatic systems are also less. So due to these reasons, the pneumatic systems are lighter compared to the hydraulic systems, wherein which here the pump, as I have already told you, hydraulic systems, pumps are nothing but the heart of the systems. So these pumps are used to provide the pressurized liquids, whereas here the compressors are being used to provide the pressurized gases. The system is unsafe to the fire hazards. It is only because, my dear friends, different in hydraulic systems you might have already studied, wherein which they use a different types of oils, and one of the types are synthetic oils. They use also use a petroleum based oils as a working medium. Due to this petroleum based oils or synthetic oils, at higher temperature, at higher operating conditions or higher pressures, there may be a chances of the fire hazards. Whereas here we are not using any oils at all. We are not using any such kind of combustible fluids over here in this pneumatic systems. It is just an air. So obviously it is free from fire hazards. So my dear friends, that is when you take the environmental safety conditions or fire hazardous conditions, the pneumatic systems are always better than the hydraulic systems. But when you compare to the working pressures and the load carrying capacities, hydraulic systems are always preferred ahead of the pneumatic systems. As now, I am not intent to say the pneumatic systems are the best or the hydraulic systems are the best. There are a few conditions wherein which we want a medium load carrying capacity or a medium pressure. Then we use both a combination of air and liquid. No, my dear friends, I want to tell you one thing here. Hydraulic systems has got its own advantages and limitations, as well as the pneumatic system has got its own advantages and limitations. That means both has got its own beauty of their importance in field of industries. So based on the applications, they select whether it is a hydraulic or a pneumatic systems. Okay. So when we talk about the basic components of the system, before I go for the basic components of the pneumatic system, I just recap what are the basic components we had in the hydraulic system. We used to have a source, we used to have a pump, we used to have a pressure relief valves or a directional control valves, then we used to have a actuators, and then we used to have a returning valves, and ultimately here and there we used to have a filters and all those things, which is a mandatory, and the control valves were also there. Now when you come to the pneumatic systems, we have an intake filter. Obviously, now even in the previous slide I just told you, pump is the one which increases the pressure of the liquid in hydraulic system, whereas a compressor is the one which has been extensively used in order to convert an atmospheric pressure, that is 101.325 kilopascals of the air is been compressed, is been changed to its higher pressure using a compressor. A compressor is the one which compresses it and to a higher pressure. So before taking the air from the atmosphere, an intake filter is been placed in order to filter it finely and make it pure and send it to the compressor. Now this compressor, there are different types of compressors are there. It can be a reciprocating compressor or it may be a rotary compressor, but the nature of work or the function of the compressor remains same thing. So a compressor is one which takes the atmospheric air, it sucks, actually it sucks the atmospheric air and pressurize it and increase the air pressure and send it to the receiver. Now, before we send it to the receiver, receiver is the one which takes a higher pressure or a pressurized or a compressed air. All are the similar words. Terminology doesn't change, it is the same thing. This compressed air from the compressor is being taken into the receiver. The duty or the function of the receiver is to only store the high pressure air and fulfill the need of an actuator. That's it. Now, my dear friends, point to be noted here. Before the receiver and after the compressor, there will be a two components which have been placed. The first one is a cooler and the second one is a separator. Now, point to be noted here, a cooler is being placed immediately after the compressor. As our standard gas law states that whenever the thermodynamics law, according to this thermodynamics law, what it says is whenever an air or a gas is been compressed to a higher pressure, obviously the temperature will also rises. Whenever the pressure rise takes place, the temperature also takes place. The temperature will also rises. In order to cool it, we want a higher pressure of the gas, but not the higher temperature of the gases, my dear friend. Please point to be noted. We want to reduce the temperature, but not the pressure. And meanwhile, we want a higher pressure, but not the higher temperature. So what we do it is we will place a cooler, which duty is to only take away the temperature or the heat which has been placed, which has been raised during the compression process. So then it will go to the separator. So the higher pressure and higher temperature air which is been coming from the compressor is being cooled, and only the higher pressure air is being sent to the receiver. Before this cooler and the receiver, we have been placed a separator. A separator function is to separate only the moist content or the air which is being present in this, and send only the dry air to the receiver. Then after this receiver, the receiver will store the high pressure air into its tank, and whenever it delivers it to the actuators, the secondary air treatment is always been done in order to remove completely the moisture content as well as the dust and dirt particles. If there is any possibilities, it has been further treated in the secondary air treatment, and then it will be sent to the control valve. Now, as you can see in this sketch, it is a button operated control valve wherein which two-way and four ports, two position and four ways section is there. Okay, it is. Now if you consider a ports P, A and B and P and A, now it is going to the first position. In this figure, it is going to the head of the piston, wherein which it is been relaxed, and the air which is at the bottom of that is been expelled to the atmosphere. Now, an interesting thing is the one wherein which there will be a pressure switch is also been there in the receiver. That means up to the limits. Say for example, it is been meant to store so and so amount of the air. It will store up to that, and after that it will releases. Is it clear? Now this pressure receiver as well, this air receiver as well as the compressor is been both is been operated with motor control center. Now this is the layout or the different basic components of the pneumatic systems which have been extensively used in all of the pneumatic systems. An intake filter, compressor, cooler, separator, receiver, then the secondary air, control valve, and then actuator. Now if you see a common components over here is, instead of pump, we common components between hydraulic and pneumatic system is that one wherein which an intake filter will also be there, okay, and actuator will be there, and then the control valve will also be there. Instead of the pump, we have a compressor. Instead of the pressure relief valves, we have a cooler and separator. That's it. Is it clear? Now there also the pump is driven by the motor. Here also the compressor is driven by the motor. Now here the receiver is an additional thing wherein which this fulfills. What is the use of this receiver? Receiver is a one which receives the compressed air, and whenever there is a more demand, it supplies more air to the control valve. Whenever there is a demand is less, it will restrict and it stores the remainder. So that is nothing but it is not only acts as a receiver, it is also acts as an energy saver. It also acts as an energy saver apart from storage. That is the beauty of these receivers. Now I am just talking about this compressed air. During the preparation of compressed air, various processing such as filtration, regulation and lubrications are carried out. Compressed air, before that is what I just shall come to that later on. Filtration, FRLE. Filtration, regulation and lubrication are all carried out. The individual components are separator or a filter, and the pressure regulator and the lubricators. Air operated systems are always cleaner than hydraulic systems because the atmospheric air is force transmitters. Leakage in an air circuit do not cause housekeeping problems, but they are very expensive. This is what the air circuit. Now, before I explain you why the air is extensively used instead of the other gases, I just want to tell you the characteristics of the compressed air so that you will appreciate why we are extensively using air instead of any other gases. Okay. Now, first and foremost thing is air, that is an availability. One thing, first point is an availability. What is the beauty of why is this compressed air is being used in the pneumatic system is because of its availability. Availability, it is abundantly available in the nature everywhere. Okay. Then the transportation. Now, transporting a liquid and the transportation of a gas are is a different issues. Say for example, if you take a mining as an example, carrying out or transporting a petroleum based liquids is more dangerous, hazardous compared to the transportation of the compressed air. Now, my dear friends, I will give you an option. If you want to transport a liquid petroleum based oils or any oil, combustible oils or a air in a mining systems. An example, I'm just taking as a mining system where you are going inside the earth. In such cases, the compressed air is more useful and more safer compared to the liquids, flammable liquids. So the air can be transported easily in pipelines and even over long distances. That is the advantage of this, one of the major characteristics of this compressed air. And then the storage. The storage, compressed air can be stored in reservoirs and these reservoirs themselves can be transported easily. Then the temperature. Compressed air is relatively insensitive to the temperature fluctuations. This ensures reliable operations under extreme conditions. As I was just telling you, one beautiful example what we can talk about is a viscosity and viscosity index. What is a viscosity of a liquid? It's, we all know it is a resistance to the flow. Does this resistance changes with respect to the temperature? Yes, it certainly changes. Now, I have a hydraulic system. I want this hydraulic system to operate in Rajasthan where the temperature goes up to 54 degrees centigrade. And the same hydraulic system I want to work it in a Jammu and Kashmir where the temperature goes up to 0 degree temperature or minus 2 degree temperature. Does this operate in the same effectiveness? No, certainly no. Why? Because the viscosity of the fluid, any liquid that you are using it in a hydraulic system, changes with respect to the temperature. That is what we standardly we call it as a viscosity index. That means change of viscosity with respect to the temperature is called as a viscosity index. So the viscosity index or the viscosity certainly changes. Now, whereas here in the pneumatic systems, the major changes in the temperature will not affect, I am not taking, it will not at all affect, it is very least effect on the pneumatic systems. The change in working temperatures does not influence this pneumatic system majorly. Okay, next one is an explosion. Obviously this explosion, compressed air does not have any risk of explosion because they are not combustible in nature. That is, there is no combustible liquids are there. If you take a petroleum or a synthetic liquids, they are combustible in nature. So there is no concept of explosion can take place in the pneumatic system. That is the major characteristics of this compressed air. The cleanliness, obviously the cleanliness is more for the air. It's a relatively low cost. It is actually the first, and this point is one and the same thing. It supports the first point, but since it is abundant in nature, obviously the cost of this air is low. I mean to say it is no cost at all. We are not paying anything for this. The ease of installation, obviously whenever we talk about hazardous things are not there, obviously it will support the ease of installation. That is a beauty. Is it clear? So you can relate one point to the other one. Now it is a simple and robust construction. It is a very simple and it is robust in construction. Availability in various sizes and stroke lengths. Whenever you are talking about the stroke lengths, it means that you are talking about variable pressures. It is one and the other thing, same thing. Okay, availability in various sizes and stroke lengths. That is a major. These are all the few of the characteristics of the compressed air. No, basically what happened, compressed air is a fast flowing operating medium. This property enables high working speeds of the actuators. When you compare the other gases or maybe other fluids compared to the any other things, this air flows very faster. That means the viscosity or whatever we call it as the resistance to the flow is very low compared to the rest of the fluids. So obviously this can operate it at a higher speeds. Whenever it has got a more flowability property, so it can operate it at a different speeds and a higher speeds. Different speeds, more than the different speeds, it can operate it at a higher speeds. The stroke lengths can be a different one also. Okay. Now these pneumatic elements are simple in construction and hence relatively inexpensive. Okay. These are all the different characteristics of the compressed air. Availability, transportation, storage, temperature, explosion, cleanliness, relatively low cost, ease of installation, simple and robust construction, and availability in various sizes and stroke lengths. And one more point what I have missed is uh, even the maintenance cost is also been less. Why? Because when in the uh, because of the air is being used, we may not frequently we have to exchange just the seals. That is a one major advantage. These are all the different characteristics of the compressed air. Characteristics of compressed air. Now the point comes to be here, why we have to use only air in the pneumatic system. It is only because of its highest effectiveness. This is an unlimited supply. There is an unlimited supply of air in the atmosphere to produce the compressed air. That is because of that. Because of this, there is a more effectiveness. The possibility of easy storage in large volume. Easy storage, it is that is true. It is only easy storage in a larger volumes we can store it. That is why that is also the reason why we use the air in the pneumatic systems. The use of compressed air. The use of compressed air is not restricted by distance, as it can easily be transported through pipes. That means from one source, say for example if you take a JCB where there will be a tank will be there and it is a limited distance. Now the source is somewhere and we use it in somewhere, it is not possible. No, in the pneumatic system it is possible, where since it is not hazardous and it can flow easily, we can have a distant, the transportation through the pipes are very easily. So the nature of the work is not restricted, is it clear, by the distance, and it is not hazardous in nature. So these are all the reasons why we go extensively for the air in the pneumatic systems. Now there are few questions based on these components as well as the compressed air. The first one is which system generates more energy in industrial applications? Obviously, in industrial applications, I have been telling you from the first session and the second session, the hydraulic systems generates more uh, power, more energy. So obviously, they use the options are the hydraulic systems and pneumatic systems, and both the systems generate the same. No, it is not. Both the system does not generate the same thing. And electric systems. Okay. Now this is obviously the hydraulic system is the option is A, which generates more energy in the industrial applications. Which type of compressor? Now the same question can also be changed like this. Which system is used in food industries, preferably in food industries more? in the food based industrial applications. Obviously, in such kind of cases, if the same option is being given, I would say the pneumatic systems, as we discussed earlier. In most of the food industrial applications, they use the pneumatic systems. It is only because the leakage of the oil will not be there, as which happens in a hydraulic systems, and it is not polluting any of the food contents, is it not? So which type of compressor requires a reservoir for compressor? It's a rotary or a reciprocating, both of the above or none of the above. It is only a reciprocating compressor which is being used to compress it. Okay. Which of the following factor is considered while selecting a compressor? Type of the oil filter required, volumetric efficiency, viscosity of the liquids, and all the above. It is not all the above. It will filter is nothing to do with the selection of the compressor. Obviously, the volumetric efficiency is not. Obviously, the viscosity of the liquids or the fluids used will influence on that. Now, which of the following is used in the generation of the air? Pressure switch, pressure gauge, dryer, and the intercooler. Dryer is being used in generation of air. Okay. Now the maximum capacity of the pneumatic system is usually 1 HP, 2 HP, and 3 HP and 4 HP. It is maximum capacity is 1 HP. The hydraulic and pneumatic circuits perform, when you compare it to the hydraulic and pneumatic circuit, performance performance is the same way for all the functions, performance differently for all the functions, perform the same with some expectations, some exceptions, and does not perform all the functions. It is performance is same with some exceptions. A few exceptions are something like this, where the pump is being used and the compressor is being used. Is it clear? No, even in the pneumatic systems, low pressure pneumatics is also called as a fluidics. That is what we dealt in previous MCQs. Now here some exceptions will be there, except that the working nature will also be the same. There also we use some pressure generating device. Here also we use some pressure generating devices. Here also we use an actuator. There also we use an actuator. Here also we use a control valve. There also we use a control valve. Here also we use a motor to provide an electrical energy or some energy to the pressure generating device. There also we use the same thing. So the purpose of using both the systems are same. To be at the end of the discussion, what we can say is both they use the same thing, but the thing, there are few exceptions will be there. Principle of working is based on the Pascal's law only. It remains same thing, but only few exceptions will be there. Maybe a pressure operating conditions will also be there. Okay, in few medium pressure required application area, they use both the combination of hydraulics as well as pneumatic systems. So that is the advantage. Is it clear? So when it comes to the maximum load carrying capacity, pressure carrying capacity, it is different. Only when it comes to the hygienity and like hygienity, like food industries, and when we have to transport, we have to carry out this pressure, the power transmission to a longer distance base, then we go for a pneumatic systems. There are a few MCQs which we have to concentrate more on this. So in this session we have discussed the difference between hydraulic and pneumatics, how this pneumatic system is entirely unique from the hydraulic systems, and the different components of the pneumatic systems, what is the uses of individual functions of the individual components of the system. And even if you have been asked what are the different components, we would say the filter, compressor, the cooler, and the separator, then the receiver, then we will have an actuator. Obviously, when we talk about the uh, uh, components of the hydraulic system, there also we come a source and then a filter, then a pump, then a pressure relief valve, then we will go for an actuator, then we will have a return pipe. So these are all the things, the outcomes of this session. I'll continue with this next session.